Hello everyone, welcome to the Internet of Things or IoT workshop, which is part of our Digital Design and Making 101 series of workshops at the University of Victoria Libraries and the Digital Scholarship Commons. My name is Rich McHugh and I manage the Digital Scholarship Commons, and I hope you enjoyed this workshop. Just in case you're wondering what IoT really is, it's a network of devices that are connected and can collect, share, and aggregate information. And what makes it powerful, it's its ability to make automated decisions in real time. For example, a thermostat knows when you're home and when you're not at home and allows you to control the temperature remotely if you want to. A coffee maker that knows when you wake up because of your smartwatch or your phone, or just knowing previously when you started the coffee maker, can be potentially a useful feature. So, what are some challenges or risks? Well, a connected network makes it a lot easier to hack into any device that's connected to it versus a wired or closed-circuit system that's self-contained, for example. If all devices are connected to a centralized hub, a hacker can control any device connected to that hub. IoT projects have a lot of moving parts and cloud-based dependencies. The main things we're going to be using today are the Arduino, which is in terms of the IoT devices we're going to be using, as a software or systems interface. The Feather Huzzah is an IoT type of board that has a Wi-Fi chip in it so that you can connect it to the internet. And the Adafruit IO is software that lets your laptop talk to the Feather Huzzah via Wi-Fi in real time. And it's a cloud-based service that allows you to do that. So here's some examples of IoT devices. An easy, simple to set up, but quite useful one is a weather station that keeps track of temperature and humidity, and those are the easiest ones because they're contained in one sensor. You can monitor remotely. Another one from Harry Potter would be the Weasley whereabouts clock, where you can, through your phone, tell the cloud where you are, and then that's reflected on the dial and that's connected to the Feather Huzzah IoT device. So in this case, it goes from the phone. Actually, there's another step here, and that's the cloud, then to the Feather Huzzah, and then it goes to the servo motor that turns the dial to where you are at any particular point in time. Another interesting one from a few years ago is the real-time election poll visualization. And this again has a servo behind it, and it pulls application programming interface that has data on polling in an election. I believe this was an American election from a few years ago, and then is reflected on the dial. And I think it's like every half hour or something, it'll update based on the most recent polls, or it did anyways. And this is how it works. The latest poll results are here on a website that allows you to programmatically access that data. Goes to the Adafruit IO cloud-based website, then is communicated via Wi-Fi to the Adafruit or the Feather Huzzah, and then is outputted the information to the servo, which turns the dial to wherever it is most appropriate. Just a reminder about the breadboards that we're going to be using for prototyping. These outside rows or columns are all connected. They're separate vertically, but connected vertically, but separate horizontally. So you got the negative and the positive that are separate but connected this direction. Then in the middle, they're connected horizontally up until the middle. These two separate sections on the same line are disconnected by the middle bit. Just a reminder as you're plugging things in how things will route themselves. So it's time for the hands-on part of the workshop, and if you're following along on YouTube, you can see a link to the hands-on activities in the video notes below. Have a great day, everyone.